que la idea es con JavaScript poder crear aplicaciones en Android o en iOS. Creo que puede ser que sea similar a Titanio, no sé si algunos de ustedes han escuchado de eso. Pero bueno, no sé, porque no conozco mucho de eso, de pronto Sebastián me puede corregir después. El experto acá es Sebastián, que es de este lado, y la otra persona que está acá es Pablo Araya, que es chileno, y se encuentra ahora mismo en Berlín. Es desarrollador de Android, pero también sabe algo de JavaScript, ¿no? Vino un par de veces a los meetups de JavaScript y de hecho dio charlas y todo. Y pues la idea fue de él, estando en Berlín, allá se mueve bastante en los eventos de los meetups y todo eso, y consiguió el contacto con Sebastián para que nos diera esta charla hoy remota. Ya, entonces, vamos a empezar. Sebastián, ¿nos puedes escuchar? Can you hear us?
Yeah, I can hear you.
Sebastián es de Londres y
Hearing
trabaja
and
para...
understanding is not always the same, right? Cool.
Ya.
Pablo, ¿quieres decir algo?
Sí, bueno, introducir un poco a Sebastián. Yo conocí a Sebastián en el meetup de Android en Berlín. Él estaba acá y bueno, su charla es muy buena, entonces por eso lo contacté para que pudiera hacer una charla para Chile. Él es uno de los evangelizadores de NativeScript y bueno, una pequeña corrección, no es comunitario porque compila nativo. Entonces, bueno, él va a dar una charla muy buena, así que pongan atención y luego ya pueden como preguntarle lo que quieran. De todas formas, vamos a grabar esta charla para compartirla y ponerle subtítulos y todo luego. ¿Ya? Así que, ¿estáis listos, Luis?
Sí, ya estamos listos.
Ya, great. Sebastian?
Yep.
Please.
Okay, cool. So I guess you guys already heard what NativeScript is a couple of times, so the story is finished. Okay, but let me do my usual introduction to NativeScript for people who've never seen it before. So basically, I work as an evangelist for Telerik, and Telerik is the company that created NativeScript. And the idea is that, I'm going to skip that, the idea is that you use JavaScript to build native iOS and Android applications, and in the next year we're going to add Windows Phone as well. And the whole thing is you use JavaScript and you use single code base for all of them in one go, which is really, really cool. So one of the first things that a lot of people ask is like, is this a PhoneGap or what is it? So the answer is it is not PhoneGap because we are not running a web view. But the UI that we generate is actually 100% native. So there is no web view, there is no HTML, there is no DOM. And the performance that you get is basically what you expect of a native application. The other comparison a lot of people ask for is, so is it similar to Xamarin? It kind of is, but Xamarin compiles the C# code that you write into native one, while our JavaScript always stays as JavaScript. We are not translating into Java or Xcode or anything else. Are you guys still there? Because I think looked like somebody dropped out. Can you hear me? Yeah. Okay. Cool.
Yeah.
So the other one is like, okay, so is it like a React Native? And the big difference is actually that and the same thing applies to Xamarin and PhoneGap, is that basically within NativeScript you get direct access to the native APIs from JavaScript. So if there is a feature that you want to use directly, you don't have to write any wrappers in Xcode or in Java. You can actually access every single function and type that is available within the SDK without writing any native wrappers. And why would you want to use NativeScript? One of the big things is skill reuse. So if you know about JavaScript and if you have CSS skills, or you know TypeScript or even Angular 2, then basically you already know the technologies, you know the languages, and basically you're already one step ahead. The other bit is code reuse. So you can actually use NPM modules that are not browser dependent. If you have already native third-party iOS or Android libraries that you really like to use. So let's say somebody built you this very beautiful iOS calendar and you want to use a NativeScript application, then you can just import it and you're ready to go. And then this is the bit I mentioned before. The access to the native APIs is super straightforward. So basically no wrappers and everything is basically exposed. And I'll be showing you some examples in a moment. But the other very big thing is actually the whole thing is open source. So basically you can use NativeScript completely free of charge. And then if you are actually keen to contribute, you could even check out nativescript.org/contribute, where we basically specify how we want you to collaborate with us and how you can help us. But if you just want to, have a go and then build the applications, then yeah, the whole thing is pretty much free. So you can go and use it. So this picture pretty much explains the story behind NativeScript. Is basically NativeScript is like a bridge between JavaScript and Android and iOS, and soon it will be a Windows Phone as well. So I'm going to show you a couple of examples of code. So one example is this is an example for Android how you could actually create a native time object from JavaScript. So basically this code here where we go new android.text.format.time, it actually goes and creates a native instance of the time Android object. And you see it's like this already using the exact Android namespace, and so that there's no magic wrapper that actually that does it for you. It's basically the whole framework is structured like that so that you can use you can access all the attributes and functions through the namespaces as they are. Okay, cool. And then the other example is like if you want to do something similar specifically for iOS. So let's say if you want to create an alert view, what you can do is actually just create an instance of UI alert view, and then you can set a message on it at the button, and then call show, and then basically you get an iOS specific native UI alert view. And so some people ask me straight away, it's like, okay, so but how would I know whether whether there's a message property, whether there's add button with title functions, like where is all this information? And the funny thing is actually all this information is in the platform's SDK's documentation. So just like the code that you see in here, all the documentation for the UI alert view, you can find it in the developer.apple.com portal, where the message property is there, the show function and add button with title is basically we are exposing what is available within the platform. So how does this work? It's actually quite clever. Basically, the whole of the JavaScript code runs on a JavaScript virtual machine. So for Android, we use V8, and then for iOS, we use JavaScript Core. And the thing is that basically on your phones, there already are those virtual machines. So what we did was just basically took advantage of it, and we modified them slightly, which I'll explain in a moment how. And then we basically, whenever we ship the applications, we pre-package the JavaScript virtual machines with the apps, and that's where the code runs. And basically, like I was showing you the previous examples, the time example for Android will run on V8, and the latter will run on JavaScript Core. So here's a small diagram that actually explains a little bit better. So your code, whenever you run it, it runs in the JavaScript virtual machine, which is at the bottom. And whenever you issue a call that has to go to the native API, to the native SDK to execute, what happens is the first thing that we do is we go through metadata. And metadata is basically the library of all the available functions and types within the platform, within the SDK. And then the next step that we're doing is like we take in all the attributes that you pass in and we run it through type conversion. So we take JavaScript types and we translate them into the native types. And once we have the results from the bottom two, we use the call dispatcher, and then basically the call dispatcher takes the converted types and the function that you want to use, the native one, and executes the call directly on the native platform. And then once we get the results back, it takes care of passing the results down the chain again. And then so if you get any results back from the native API, then we'll take it and translate it into the JavaScript types and then pass it back into your code. So I hope that makes sense so far. So this metadata bit, it actually deserves a bit of explanation. So what we have is there's this thing called, let me close this. There's this thing called metadata generating process. And then you don't have to actually worry about it, but that's something that is automatically built into the build process of the application. And so what the metadata generating process does is when you build your application, and let's say you want to build it against Android API number 22, so the metadata generating process will go through the API 22 SDK and then find all the functions and all the types, and then it will take them and inject them into the JavaScript virtual machine. So if I come back very quickly to this example, so if you went on V8 and tried to call android.text.format.time from Chrome, then you get an error saying like, hey, there is no Android. But because of the metadata generating process and us injecting all the namespaces, this is available from within NativeScript. So, and that's the main premise of how the whole thing works. And the big benefit of the metadata generating process is that basically you get day zero support. So, for example, if there's a new version of Android or new version of iOS coming up, and let's say Apple decided to introduce a teleport mechanism, right? So if you call this function and you say teleport and provide coordinates, your phone will get teleported. And if you want to use that feature, all you have to do is just update Xcode on your laptop and then basically build your application against that the latest SDK, and you'll be able to use the latest function. You don't have to wait for us to actually implement anything. Everything is fully automated. So, and if you're interested in like how the whole runtime works, and it's actually quite a beautiful bit of C++ code. So you could actually go check out in github.com/nativescript and then /is runtime, or the same for Android runtime. But it's only for people who are crazy with C++, I swear. So let me show then in a bit better example of how all those pieces work together. So if you want to, let's say, create a file object in Android, and we call new java.io.file, and we provide a path, the V8 will take it through the few steps. And first thing what we'll do is we'll have the type conversion service, which will take the path and then convert it into Java lang string, which is the native Android string. Then the metadata will go and then find a constructor for creating the file, and then finally the call dispatcher will execute that, and we'll get like a dual result. So what we'll get is basically on the Android side, we are going to get a native file object, and then on the NativeScript side, what we're gonna get is like a custom proxy object, which is linked with the native one. So whenever you make a call on the custom object from JavaScript, that gets delegated to the native one. And if there is an event that is raised on the native object, that event would then be passed into the proxy object. And the best thing is that it's actually, most of the time, you don't even have to be aware of this process and this mechanism, but it's worth knowing to know how it works from inside. And now we're getting to the point where, okay, it's all good. You know, you can build your application writing Android code or iOS code using JavaScript, but that still doesn't, you know, help you in any way, because you still have to kind of build your application twice. So that's why the next step is we have this thing called NativeScript modules. And the idea of the NativeScript modules is that is basically a bunch of components that they wrap up the logic to use, let's say, the native Android and iOS components into like a common layer. So this is basically a special abstraction layer to allow you to get access to a lot of features, to get access to the UIs, to get access to different web services or animations, or pretty much quite a lot of different modules within the applications. So that, can you make me the presenter? No. Sorry. So it's basically, so because of this abstraction layer, you can almost forget that you're writing the code for either Android or iOS. Is basically you write your code using the abstraction layer, and then when you build the application, at the moment when you build it for Android, that code gets translated into either to Android, or if you build the application for iOS, that gets translated into iOS. And then using the mechanisms that I explained before, you basically execute either on iOS or Android. So a good example, so looking at our file example as we were looking before, if you wanted to, let's say, create a file for both Android and iOS with a single code, all you have to do is require a file system object, and then you just say, using the module, you say file system module.file, provide a path, and when you run it on Android, you get this bit of code in the middle. And if you run it on iOS, it actually would translate into this very verbose code for iOS. But pretty much like all of this is done for you, which is quite clever. Another example of one of the modules that we have is HTTP module. So very often, if I tell you like, oh, can you go and call this web service from JavaScript, and you're thinking, okay, I'm in JavaScript, so what I should probably do is make an AJAX call, and this will work 100%. However, both Google and Apple put a lot of effort to actually build a native way of calling web services. So what we did, we actually built a NativeScript module just for that, so that you can actually call web services natively rather than just through AJAX calls, which will give you a lot of performance boost. And so as much as there is quite a lot of modules that we are building, obviously we cannot build everything ourselves. And luckily community comes in handy, and there's various modules that people are building. So if you go to npm.js and search for NativeScript, then basically you can find quite a lot of modules that are already out there. So for example, you could see native SQLite or text-to-speech, or a few other ones which can be quite useful. So so you kind of know how everything works from inside, and how can you turn it into an app. So there are two options. So the first one is Telerik Platform, which is our paid proposition. So what Telerik Platform does is it actually allows you to make the builds in the cloud, so that all you need is pretty much just a web browser, and we have all the setup configured in the cloud, and then you could even use a Windows machine to build iOS applications, because basically we have a Macs on the cloud that we use for building your applications. And the second option is a command line interface, which is completely free. So if you have, let's say, Android setup on your machine already, all you pretty much need to do is just call npm install -g NativeScript, and then you can use the CLI, which is part of our open source package, and allows you to build applications free of charge. I'm probably gonna skip that. So so basically CLI, if you want to learn more about it, you could probably check it out in GitHub, which is completely free and open source. The one big thing is that basically, if you want to use the command line interface and you want to build Android applications, then you have to have JDK, Apache, and an Android SDK installed. And actually, as of not yeah, this slide should be updated 2 months ago. 2 months ago, we actually introduced Gradle Build. So what you need is actually JDK, Gradle, and Android SDK. And for building iOS applications, you need Xcode, Xcode CLI tools, and iOS SDK. And you need to have a Mac if you want to use the command line interface. And how you would use it is actually quite simple. So once you have NativeScript installed, you will get this shorthand for our commands, which is called TNS. So if you call TNS create and give an app name, what this will do is you will connect with our repository in the cloud and then download the necessary bits to create your project. And then when you go into that folder, if you're building iOS applications, then you basically have to say, okay, I want to add iOS platform. And then once that's done, then you can call TNS run iOS, and then this will build the application and run it on the connected device. Or if you do -- emulator, you run your app in the emulator. And then the second thing is, if you want to do the same thing for Android, then basically you just say add TNS platform add Android, and then you can just run Android applications. So there's a little bit about the project structure. So when you create a project, you get a few things. So let me start from the bottom. There's this platforms folder at the very bottom, and this is basically when you do platforms add. That's where these two folders, either Android or iOS, get created. And as well, these are build folders. So when the application is built, all the binary files and everything that is required to make the build, they move into these folders. The other part is in here, we have this folder for node modules. So node modules is pretty much like our abstraction layer goes in there, or any module that you want to add into the project, they'll all be going there. And as well, when you build your application, like you can see the main page part, you have the CSS, JavaScript, and XML files. So basically, JavaScript is where you write the business logic of your application. XML is what we use to define the UI, and then CSS is what you can use to actually style your application to kind of make it a little bit prettier, or make it actually look professional rather than standard ugly Android or standard ugly iOS. Because if you don't do anything, those apps will be ugly by default anyway. So, and like I mentioned before, you can use CSS. So I think there's a little caveat in here where basically it is not CSS. CSS is basically the equivalent of CSS. So pretty much for any property that we allow you to, let's say, set the color of the font, or change the font size, or set the width and margins and everything, we have to actually implement each of those. So it is CSS because we use exactly the same syntax and structure and the same rules, but we have to implement all the attributes. And then basically, if you want to see what of the styling attributes are supported, then it is all in our documentation. So it's actually basically the link that is at top of the page, and you can actually see what's possible at the moment with styling and what's not. And I think, since I mentioned at the very beginning that basically the application that you're building doesn't have a home view. You know, it is not a web browser. You cannot just, like a lot of Cordova people will do, you cannot just put a div in there and start playing with it. You know, there is no such thing as div natively on Android or iOS. So what we give you instead is actually there's 5 main layouts that you can use. So there's the absolute, doc, grid, stack, and wrap layouts, which allow you to actually set up layout your application so that it actually can look professional. So the absolute layout, which is quite obvious, you can set the exact X and Y coordinates where the components should be rendered. Then we have the doc layout, where you basically say, okay, I want to have this bit on the left, then this bit on the top, then thing on the right, then something on the bottom, and the final thing, you know, put it in the middle or wherever there is empty space left. Then the other one is grid layout. So grid layout is more like it's basically a table. So you at the very beginning can set up, say, I want to have this many rows or this many columns of this and this size, and then within there you can actually place your components. So you can say, okay, I want to put this image in the column 1, row 2, but I want this and this button to be in the column 2 and then row 0. So you can kind of arrange it based on the table. And then the easiest one, and the one that actually I tend to abuse the most, is stack layout, where basically say, as you keep adding the elements, they kind of get stuck below each other. Or if you change the orientation to vertical, then they will be like next to each other, next to each other, next to each other, like to the right, to the right. The problem with stack layout is if you go, for example, vertical, and you have a bunch of images. Let's say your screen is 800 pixels wide, and you have 10 pictures of 400 pixels. So what's going to happen is we're going to place the first picture, then the second picture, and the third picture will pretty much go off the screen, right? So basically the rest of those pictures will be off the screen. So that's why we have the wrap layout, which basically will allow you to say, okay, put one picture, another one, in the third one doesn't fit in a row, then put it in the new line. And then this example could be very good for a gallery, right? Then you throw 10 pictures, and they will very nicely be laid out on the page. There's a lab that you could actually try, which has a set of instructions, and you could play with it. I'll be sending the slides later on, so you could also check the links later on. If you're interested in NativeScript, you could actually, if you're ever in London, because that's where I'm based and I'm running my own meetup here, you could say hi to me at NativeScript London. But as well, you can find a lot of information at nativescript.org. That's our main site for our documentation. And you could actually either follow NativeScript or follow me, which is Seba Vita. So what I'm going to do now, I'll show you a little bit of code so that you actually can see it in action. So I'm going to use our Telerik platform for it, and I already have preloaded the project, and I'll take you through a few examples. So the first thing is, let me show you how to do.
Sebastian?
Yeah.
1 second, please.
Yeah.
I don't know if they can see.
Can you see my code?
No, it's so. Maybe it's so small.
Should I make it bigger?
Yeah.
Felipe, ¿es okay?
¿Se ve bien o no? ¿De ahí fondo? ¿Sí? ¿Alguien ve? Tienen que responder usted. ¿Sí?
It's okay.
You can always come closer to the screen.
Can you make it a little bit bigger?
Even bigger, okay. How about now? If I make it bigger, there's like the whole screen will be just text.
Sí, sí, yeah.
Yeah? Okay, cool.
Yeah.
So
great.
if we want to, let's say, create a hello world example, that's going to be interesting. Where are my components? If you want to create just a hello world example, all you have to do is pretty much have a page tag, and then in the middle you add yourself a label with a text, say hello world, and that's pretty much what you need to create a hello world example. And then the next thing that what you can do from within Telerik platform, I can go into build the application, and then from here I can say I can either build it for Android or iOS, and I have two options. I can either use app package. So the app package is the usual way where the build will build an app package, you download it and you can put it on your phone. Or the second option is we could use a companion app. And the companion app is basically an app that you can download from App Store or Google Play. And then this app kind of connects with your project. So if I choose the companion app and go next, I'm going to get a QR code. So from within the companion app, what I can do, let me bring my phone. I can take the companion app scanner. I can scan the code, and basically this connects my companion app with my project. And straight away you can see, let me bring it back, where is it? Lost it. And then you can already see there's a very tiny here hello world in here. So there's, at the moment, like I didn't have to fiddle with cables or download any packages or do anything else. It's pretty much the application got connected straight away with my app. So obviously hello world is not the most impressive example, so I'm going to show you the next thing. So one of the things is app.js is basically a file where we have this thing called application main module. So in here I can specify what is my first page. So I'll be taking you through a few examples here. So I have this other example called sign up. So I changed it. So I'll take you through sign up in a second. So the sign up form is basically the idea where I have a stack layout at the core, and then basically I say, okay, I have a label that says name and a text field that captures the name. Then I have email, text field, and then label and text field for a Twitter handle. Then I have a button, and then I have another label where I can display the results. So what now I can do is I don't have to rescan the code anymore. What I can do instead is basically come back to my companion app and call sync. And then basically, since the companion app is connected to my project, it will go back and then synchronize with the project. So now you can actually see the form that shows the name, email, and the Twitter handle. And then, so what happens is, I'll show you the bit of JavaScript that sits behind it. So I have in here this thing, and by the way, this is the wrong way of doing it. Where this is like the old style, where I'm basically going and say, okay, go into the page and then find the name component, find the email component, find the Twitter handle, find the sign up button, and all of those is basically based on those IDs. So don't worry, this is not the way of doing it. So once I found all those components, then basically what I can do is say, okay, I want to capture sign up button, and then add the on tap event. And then from here, what I'm doing is saying, okay, if any of the name or email or Twitter handle text fields are empty, then I want to print an error message. Or if they're all filled in, then I want to like print out, all the details. So let me show you that quickly in action. So basically now, if I press sign up, I actually get like error, all fields required. But if I say Sebastian, .com. That's not my real email actually, but I'm lazy. That is my real Twitter handle. Then yeah, we get a message. But at this point, we can do even something better. NativeScript has this thing called animations. So we could actually animate and do some tricks to one of the components. So I already have this function that should be run on animate. So what I'm going to do is, if the fields are not filled in, I am going to take my sign up button and pass it into the animate error function, and that function will basically say, I want to run it through a few animations. So first you go set the opacity to 0, then you set the opacity to 1. So basically you will fade out and fade in again. Then we have translate, which will basically move it 100 pixels to the right and down, and then put it back. Then we'll make it run it through scale, so make it bigger, smaller, and then we'll do a bit of rotation. So if I save this and rerun, call sync. For example, now if I press sign up, you see the sign up button goes a bit crazy. So obviously this is not the best usage of animations, but this is the idea, just to show you that these kind of things are possible. And those animations are actually native. So it is not something that NativeScript actually tells the component to move bit by bit by bit, but it's actually going straight to the Android layer and saying, take this button and run it through those steps, and then this is like, you know, super smooth and runs directly on the platform. So since I said this was the bad way of doing it, there is a bit better way of actually building your UI. So the next example, which is half good, is not perfect just yet, is a journey calculator. So let me update my app.js to point to it. Save that, and this time I'm gonna start with showing you the example. Sync. Are we there yet? Okay, cool. So this example is basically we have few text boxes and we want to capture how many miles you travel, what's the miles per gallon, so that's like efficiency of your car, and how much does it does the fuel cost at the moment. And if I press calculate, it kind of tells you, you know, what's the journey cost and cost per mile. So the way this application works, and let me this time start with JavaScript, is as follows. We start at the beginning with just very simple JavaScript object. And then this JavaScript object has attributes like distance, miles per gallon, and fuel cost. And then when I create the page, so I have this loaded event. So on page loaded, I call load sign up view, which is this function. So when the load sign up view gets executed, what I'm doing is saying I'm grabbing the page and I'm setting the binding context of this page to journey info. So now my journey calculator, this view, knows of the journey info object, right? So now that I have the binding context, I'm gonna keep it on top for now. I can do this thing where, for example, I have my label for distance and I have a text field that captures the distance. And here's the thing that I'm doing. I'm using this double curly brackets notation, the handlebar notation, where inside I'm saying, I want you to bind this text field text attribute to distance. So this distance is bound to this attribute here. And the same thing goes for the text field for miles per gallon and the fuel cost. Right? So now, because of this binding, when I call calculate, you see, I don't have to go and retrieve the text box to get my 24 and 30 and 120 and a half, or even if I change it to 50 or let's say 40. See, this still works. This is not rigged. Look, you see, at no point do I have to go and say, go and find that text box. I'm basically just straight going, go to journey info, get the distance, get miles per gallon, get fuel cost, do the calculation, and print the result. There is one issue with this particular example, and that's basically because this is just a basic, this is just a basic JavaScript object. It doesn't have any mechanism to actually go back to the view and say, hey, I updated myself. So what I had to do, I still had to go and retrieve my result label where I want to print the result, and then print the text in there. So the final solution, which pretty much is the proper way of building application, is actually, if this was an observable object, which basically is able to communicate both ways with the UI, then basically I could actually have in here, you know, like a result flag where basically I could pass in the messages and then bind my label to it. But unfortunately for this example, I didn't do it. So that leads me to my final example. And it's a game where I'm saying everywhere I go that I'm gonna make money out of it one day. It's absolutely amazing. Pablo already knows it. I think he played it twice or 3 times. So let me bring it. Where is it? So, bam, bam, bam. Okay. Let me hide that. So this is what it is. Actually, let me refresh very quickly. So let me first show you what it is, and then I'll take you to the code. So basically the idea is where you have a game, you can start a new game, and basically there are numbers from 1 to 10 that are put in random order, and you have to be guessing whether the next one is lower or higher, and if you guess correctly, you get points for it. So I am not doing particularly well, but yeah. So the way this is built, now I can make the code bigger. What I'm doing is I'm starting by creating an observable object, requiring an observable module, and with this observable module, I'm creating an observable object, which I call up-down view model. So that's my view model. That's where the game engine is going to sit. And then my view model basically contains information like number of cards or stuff like what's the current card, what's the score, what's my streak, how many cards do I have left. So it has those attributes, but as well it has functions like start new game, go higher, or go lower, and then many other functions that are necessary to run it. So once I build all of this, and here's the funny thing, is actually this view model or this game engine that I built is completely UI independent. So I could actually run this code in just in console to verify, to test it 100% that the whole engine works properly. So now that I have this view model, what I can do is go to the code, the JavaScript code behind of my actual view, and I can require it like I was requiring other components. So I'm requiring the up-down view model, and then on the load event, I'm setting the view model as the binding context of my page. So once that is done, then what I can do is basically this, where, let me bring the screen back again, keep it on top. So now I can do this thing where my new game button is bound to start new game function. And for example, the go lower, go higher is basically button is bound to go lower and go higher functions. And then my current card, which I'm displaying right now, is basically a label that is bound to current card, but as well I can use expressions. So this expression here that says cards left :0 they're not two labels, actually one label that has this whole expression in one place. So I'm basically concatenating together, and the one below even use two different attributes. So that's the clever thing behind it. Obviously, if I try to sell you this game, you know, I don't think I probably wouldn't even get a chewing gum out of you for that. So that's why what we can do is actually add a bit of CSS around it. Let me sync it, and we can make the game look actually a little bit better. So I'm a coder, I'm not a designer, so I'm pretty proud of it. So please don't laugh too hard on me. I can't hear you, but I know you're laughing. So this game already looks a little bit better. My buttons, you know, are much bigger. You can actually see the numbers when you're trying to go lower or higher, and you can see the points, etc., etc. So the code for it is actually quite straightforward. Can I hide it for now? Yeah. So let me show you that very quickly. Where are we? So the first thing that I have is actually this bit of CSS. So I have tags like styles for info, info label, I have a card, and I'm saying, like, you know, all buttons should be vertically aligned to center, and, you know, they should be kind of like a bluish, etc. And then, for example, the card is basically the card is basically this thing right in the middle. So I'm saying that this card here, the font size should be set to 80 with like this dark reddish thing. And then once I have this CSS style in my, where is my XML? In my XML, I have this attribute called CSS class. So coming back to the example, let's move it a little bit here. So for example, these two are basically, so we have cars left, that's CSS info label, and these two are info labels, while the two below, they're of class info. While the buttons themselves, they don't have any class, because basically what I said is, all the buttons should be like this. And that's the main idea of some of the things that you can do with NativeScript. Guys, do I have still a little bit of time, because I want to show you a little bit of the command line interface? Pablo? Oh.
Now you have audio.
Pablo is muted.
Yeah.
Okay. Yeah?
Yeah.
Do I have still like a couple of minutes? I want to show you the command line interface, because I think that'll be interesting for you.
Yeah, great.
Okay. So when I was saying before that if you say like TNS create, I already done it because that takes like half a minute. If you call TNS create and then give like project name like blah blah, then this will go create a project. Oh no, I don't want to do that. No, damn it. I was not gonna do that. Let me kill it. Too late. Okay. I'll just very quickly show you the command line itself.
Thanks.
So basically the idea is that what I can do is I can call TNS run Android, and this will build the application that I already have on my machine and then put it directly on my phone. But you already seen running itself. I want to show you live sync, which is much more fun. So I'm going to do live sync watch Android. And then what this does is like prepares the project very quickly. And then it's very similar to pretty much like a build. You run the application, but as well, the application code that I have in here is basically there's a file watcher on top of it. So every time I make any changes to my app, basically the app will automatically refresh itself. So the first time it usually takes a little while, hopefully not too long. If not, maybe I can show you another time. Come on, almost there. Okay, so here's my app. The code is very, very basic. Each time I press, the number of tabs go lower. But now what I can do, keep it on top. If I, for example, go change this to 50, save it, the app goes and then refreshes itself. And this, like, I can make changes to pretty much anything, and this applies to all XML, CSS, and JavaScript. So instead of tab, I can say tab now, save that, and then that pretty much goes and refreshes itself. Or I could go into CSS and then change the title to font size to 80, and that probably go way too big. But you guys get the idea, so that you can actually make the changes really quickly. And actually last week we even introduced fastest live sync that doesn't even go through the refresh thing. It's just I haven't touched this laptop for a month, so I forgot to upgrade it. And the final bit that you can do as well with command line is you can run a debugger. So if I run TNS debug Android, then basically that builds the application, and it will start with Google Chrome tools, and then from within there internally you can do the debugging of the code. And that's pretty much the last thing I want to show you. Do you guys have any question while this is preparing? Anything? Or actually, this was faster than I thought.
Yeah, Sebastian, now they have audio.
Yep.
La traducción o algo, no sé si te resta el conflicto. No hay problema. No es que no puedo de repente React nativo que quiera.
Sebastian.
Yeah.
Sebastian.
Yeah.
Can you hear me?
I can hear you, but can you hear me?
Yeah. I can hear you. I just have one question, because I've worked before with some tools like Titanium and React Native, and I just wanted to know what would be like the big advantages against those technologies for us as developers. What are the main advantages in using NativeScript?
So one of the biggest thing is the direct access to the native APIs. So with React Native or Titanium, you still have to write the wrappers. While in our case, you actually have direct access to all of those from JavaScript. So that's one of the biggest things. And I think as well, the size of the team that is behind NativeScript might be a big advantage, because I think our team that works around NativeScript is around 30 people. So Telerik is actually itself is actually quite a big company in general. So it is not that we are a startup, we're trying to create something new. It's basically we are a proper software company that's been working on it for a while already. I think these are some of the things, and I think the tooling that we are offering can be quite a big advantage. So like I mentioned before, we have this thing called Telerik Platform, and from within Telerik Platform, we have tools like Screen Builder that allows you to very quickly build the application. So it's almost like you don't do drag and drop. It's more of like, I want to have a screen for login page, or I want to have screen that displays this data. And what happens is the tool generates the whole views that already connects to backend services, etc. So I think this is quite a big advantage itself. But yeah, there's lots of other. And the other thing is we do support as well building with Angular 2. Which is quite a big thing. So you could actually, by using Angular 2, you could build with single code, desktop, web, and mobile applications.
Great.
So, yeah.
I don't know. ¿Tiene otra pregunta? Other question?
Sí, un segundo. Can you guys hear me?
I can hear.
Yeah. Yeah. Is there any specific XML that you guys use, like different, non-open in a way?
No, it's just standard XML. It's there's nothing particular about it. The only real thing is like the tags that we're using, like label or stack layout and these kind of things, is something that you probably have to go to our documentation and learn it and check out. But it's nothing that would be very surprising. And if you ever seen XAML in the past, then a lot of things, the way we structure things is very similar to XAML. I think that's the thing.
Yeah, thanks.
Yeah. By the way, the debugger loaded in the meantime, so I can very quickly show you that when the debugger loads, you actually get Google Chrome tools. So now if I like press on something, like I already had a debugger stuck in here, so you could actually step through the code and even like manually change things, like say this dot counter equals 100. And if I let it run, you see this even updated here, etc. So if you ever use Google Chrome tools, that's sort of a debugging thing that you get from within NativeScript. And this is part of the command line interface, which is open source. Do you guys have any other questions?
No.
Oh, there's one thing I should probably do. All the examples I showed you were really ugly. They're quite horrible, but you can actually build apps that are quite nice as well. So this one is actually using our native Android list view, where you can do like with Gmail app, where you can slide to one to another. You can delete items, or you can go like or unlike them, go into favorites, and etc. etc. So the apps can look nice, So it is my fault that the examples were horrible, But that's the idea. Yeah, don't let me show you more things, because I always have something to show.
Don't worry.
So, what do you guys think? You want to give it a go?
I do.
Yeah?
Yeah.
Good.
Where, I mean, can you put again the slide where we can find more information? Just
Yes, sure.
to at
So,
least take a picture of it or not.
so one of the best places is go to nativescript.org, which is this website here. And then this is where we have all our documentation, etc. And then as well, I'll follow up with my presentation. I will send it over, and yeah. So I'll send you all the links, etc.
Yeah, I can publish all in the group on the meetups.
Cool.
So great.
All right.
Yeah. I don't know.
All right. Thank you. If you guys are hungry for more, like you can have another session that I can do like in a few months or something. So I would advise go try it yourself. And I have a session where I'm explaining how you can expand this and how you can build your own components. So if you're interested, give me a shout and I can always come back.
Yeah.
Maybe next time I'll fly over.
Pablo, ¿no puede?
Yes. Thank you very much.
See you guys.
Gracias, Pablo.
Thanks for having me. Bye.